everyone? Should I start? Sure. So we are going through some examples. Today we'll go through some more about the measurement of reinforced concrete structure, and we are talking about the superstructure, which is above the ground. Okay, the NRM sections are shown to you. What are we talking about? Beams, columns, and slabs. And we are mainly talking about their concrete and formwork. We already finished the reinforcement of these items earlier, especially for the columns and beams. We have done it. Am I going too far? Yes. Okay, this is the example which we did last time, including the beams, columns, and slab. Now I'll show you something which is already done in the slides. Okay, did I upload them? No, right? I didn't upload them. Okay. So this is the plot we have. Okay, you can see all the columns are square columns, and all of them are 300 by 300. Okay, we have 250 mm RC wall, ground floor only. Okay, and then we have what? You can see the floor to floor height, the floor to ceiling height. Okay, and then you have the beam as well. The beam is how much? Where is it? Is beam written somewhere? All beams are 300 by 300. I don't know why, but they are. Done? Okay. And the slab is 150 mm. Okay, again reinforced concrete. This floor bed is also floor slab, heavier, 200. You can see the floor heights are different. They are not the same. What else? You can see there is a blinding under the footing, 50 mm. Then there is a footing of 300 mm. Okay, and then there is this, which is column or beam, whatever you take it, 300 mm. Okay, column. And what else? Yeah, under the slab, I have 150 mm of hardcore. Okay, and so total is 350. Slab 200, hardcore 150. Clear? Huh? What is hardcore? What is hardcore? Type of soil. Type of soil?
Is it a slab?
No, it's not a slab. It's not a slab. Type of soil, sort of, because it's loose material. It's not concrete. Okay, but it's not the soil. It's not the natural soil. It's not backfilling. To clarify, it's not backfilling. Okay, hardcore is not backfilling. Hardcore is a material which you will definitely take from somewhere and you put it. If you go back to the slides, the previous slides, you will see the pictures of the hardcore. So it's basically like an aggregate bed. Okay, it's like an aggregate bed. Okay. So any other thing? Clear? Okay. And you can see the height from here till I don't know where, somewhere. Okay, middle of the slab. Okay, it's from the footing to the middle of the slab. Okay, 1.5 meters. I don't know. Clear? Okay. Okay, all concrete will be, so I will go through the calculations right now. Okay, later on you can do it yourself, and the good thing about this example is it is like a revision which you badly need of the last topic as well, right? Okay, so they start with substructure. Substructure is under what? Under the soil, under the slab, under the roof, under the sky. Clear? Very good. Yes, you were saying something? Under the ground, under the what? Floor. Okay. Under the floor, yes. Floor, yes. Okay. So the depth is 150, 1.5 meters, as I showed you in the previous this one. Okay, plus 50 millimeter of blinding. Okay, there's 50 millimeter under the footing. Okay, and what is the difference between the footing and the blinding? Blinding is concrete and footing is made up of wood. Footing is made up of what? Concrete, right? What is the difference between blinding? Oh, same shirt, huh? Yes. One bonus for him. Huh? Blinding is a cover for footing, sort of. Okay. Yeah, but it's weaker. The concrete is weaker. Okay. Then we have the topsoil, as you know, topsoil, 150. Okay. 150, 200 normally. Okay. So the total depth from here to the bottom of the blinding. You will do the excavation to the bottom of the blinding, right? Excavation is included in the blinding. Okay. So total will be 150 up to here, 150 up to here, plus 50 meter of blinding. Okay. Now you don't have to do the total excavation because from the top you will already remove the topsoil. So you can see the topsoil is subtracted from this height because topsoil removal is separate, right? Okay. So you get, after removing the topsoil, you get 1,400 millimeters of the height of the excavation. Okay, 1,400 millimeters is the height of the excavation after removing the topsoil. Got it? Clear? And it is from the ground, not floor, ground till the bottom of the blinding. Okay. Then they are calculating the width and the breadth of the width and the length, width and the breadth, whatever. Okay, for this excavation and topsoil. Okay, so you can see the dimensions from the top plan. This is 6,000. Okay, now 6,000 is 6,000 is internal. Right? No, 6,000 is center. Clear here? Yeah, 6,000 is center to center. Okay, so you will add half of the column from here, half from the other side. Okay, and that one on the top. Okay, this is center to center 3. Okay, center to center 3, and we have 3 panels like this. Okay, so 3 into 3, 9. Okay, and then again you add the columns on both sides. Okay, this will give you like the external girth. This is like the external girth. They give you the center line dimension, right? So when you did all this, this will give you external girth, the external perimeter of the building. Okay. Now I told you we do the excavation for the topsoil up to what? Internal, external, center line, or something else? Center line. He is very busy. Totally in the office mode, huh? Coffee here, laptop here. Let this guy go to hell. Yes, center line, yes. Go ahead. Center line. Everybody agrees, right? Like you guys have a plan to get a D in the course. All of us together, right? Then we will blame Dr. Onab. Huh? Topsoil and excavation up to the projection of the footing. Okay, topsoil and excavation is up to the projection of the footing, not center line. Center line is for excavation of the footing itself. We are talking about topsoil. Okay, topsoil. So for that you have, this is 300 millimeters. Okay, this is 300 millimeters, and you have up till here. So I have to add this much. Okay, this thickness is how much? Written somewhere? Is it written? Or they are just going over it? Okay, it is 1 meter. 1 meter is what? This thickness. Thickness or what? Width of the footing. Width of the footing is 1000, 1 meter. From there you will subtract the column, 300 millimeter, or the wall, whatever you call it. Okay? You will subtract and you get this plus this. The remaining is this plus this. Then you do the half, you will get only this much. Okay? So in the external dimension, you will add this much. Okay? This is what they are doing. 1000 minus the column. Whatever you are left with, you will do the half. Okay? You can write multiply by half, or you can write 2 and the bracket and this one. So this means the same thing. Okay, so this is the spread or the projection of the footing. On one side, you will add it on both sides. Okay, so external was 6.3, right? And 9.3, right? So you will add 350 on one side, 350 on the other side. Okay, so 6.3 plus 0.35 plus 0.35. It will become 7. 7. Okay, and 9.3, 0.35 on one side, 0.35 on the other side. You add them, you get 10. Okay, so this becomes the dimension for topsoil removal. Okay, clear? Everybody? Any questions? Okay, I'll come there and check.
It's your representation one.
Huh?
Because we don't want them to present on 26 and they have exam.
Who?
My group
I don't want them to do what?
present to postpone because they have exam. So I have to work on it now.
Oh my dear.
Why because of you?
She is the only one working, see? The only one who will do the presentation on Thursday. Right?
I
Right?
have exam on Thursday.
So what are your group members doing?
But we are working not individual, we are working in group.
Where
So
is
we
your
should
group?
someone sit together. We should present it. Postpone it on 26 and then it's
You have exam, I will postpone it for you. Why for the others?
because it's a group work and it's group collaboration.
Everybody else presents their part. Okay. Same thing for the bulk excavation. Okay, bulk excavation is till the end of the hard core. Okay, bulk excavation is till the end of the hard core. So you are here. Okay, and hard core is 150. Okay, hard core is 150. So the area is same, and the thickness of the hard core which is already given. Clear till here? Any problems? Any questions? Okay. Then we have excavation for the footing and disposal of the material. Okay. So excavation for the footing we have the footing is square 1 meter by 1 meter. Okay. So the first two dimensions 1 and 1, breadth and width. Okay. 1.4 is what? The height. Okay. Height is from where to where? From the bottom of what? The height 1.4 is from the bottom of footing to, okay, from the bottom of blending, yes, from the bottom of blending to what? So we start from here. This is the bottom of the blending. Where is the end? The bottom of that topsoil. Okay, there is no slab right now. You are doing for the excavation, right? Okay, slab will come after. So from the bottom of the blinding till the bottom of the topsoil. Okay, and this is where we calculated it. Look at the top. Okay, we already did it. Okay, so they are saying all this material will be excavated and all this material will be disposed of, all of it. Okay, they will not use it again, and obviously because they will fill it with concrete. Okay, so that's why. So we have the same quantity for filling and disposal, and this is the description which you see here. It is taken from NRM. Okay, so you don't need to worry about from where we are getting not exceeding 2 meters and so on. Okay, this is all coming from NRM, or it will come from the specifications. Okay, Then we have the blinding concrete. Okay, blinding concrete is under the footing, right? Footing is 1 meter by 1 meter, and the blinding concrete is 50 millimeters thick. Okay, 50 millimeters thick. Now the rule is that the thickness of the blinding is the same portion by which it will go beyond the footing. Okay, so you have the same size as the footing and the thickness of the blinding. Okay, in some cases this thickness is taken as the extra amount which you will go on the side of the footing as well. Okay, so it will, if the footing is for example 1 meter, okay, and the thickness of the blinding is 50 millimeters, so 50 millimeter thick, 50 millimeter extra on one side, 50 millimeter extra on the other side as well. Okay, this is also a very common practice, that the blinding goes extra equal to its thickness on each side. Got it? But here they are not doing it, okay, for whatever reason. But as I said, it is just for providing the base for the footing. Okay, it has no structural purpose. So same size as the footing and multiply with the thickness, and you can see the number of footings are 8. So the number of blinding is also 8, and the number of footings you will get from the plan. Okay, there must be a footing plan and a foundation plan, where you will get the number of footings and blindings. So here you can see, okay, you can see 4 columns on one side. Okay, so under each column there will be footing, right? 4 columns here, 4 columns there, total 8. Okay, then we have concrete for the footing. We know the size of the footing, 1 meter by 1 meter. The thickness of the footing is, you can see over there, 300 thickness, height. Okay, so 1 meter by 1 meter into 0.3. And what else? Concrete columns. We are doing it for substructure. Okay, so this is column up to the floor level. Okay, the floor level. Okay, not the full column. So up to the floor level, all columns, as you can see on the top in the plan, written 300 by 300 millimeters. Okay, usually keep the columns same. So 300 by 300, and then you take the height. Okay, so the height is it was how much? It was 1.4 up to the bottom of the blinding, right? Okay, from the ground to the bottom of the blinding. Okay, but it was written somewhere. So, for example, it is, it was, yeah, okay. So, so you have 1.4 from the ground, from the bottom of the, from the hard core. Let me do it on the board to make it easier for me. Okay. This is my footing. This is my blinding. This is my column. Okay. And this is my floor level. Okay. The slab is 150. Okay. The hard core is how much? No, the slab was 200. Sorry. The slab is 200. The hard core is 150. Okay. And I did the topsoil, okay, and then this one. So from here, from the bottom of the topsoil up to here is 1.4. Okay, this is 50. This is 300. Okay, and I want to calculate the height of the column up to the floor level. Okay, so this is what they are saying is 1.2. Okay, how did we get it? 1.5 up.
No, the total not 1.4, 1.4.
No, 1.4 is from where to where? From the blinding up to the bottom of the topsoil, right? The bottom of the topsoil. Okay. 1.5 is from the footing. 1.5 was from where? From the footing to the ground level. To the ground level. Okay. This is the height of the excavation. This is the height of the excavation after the topsoil. Okay. So from this height you will subtract 50. Okay. You subtract 300. We are talking about the column, right? Okay. You will subtract this, and then you will add this one from the top. Okay. Because we want column up till here. Clear or not? Okay. So from 1.4 you will, there must be something. Okay, how much we will get? Tell me. If we take 1.5 from there, so 1.5, then you subtract the footing, which is how much? 300, right?
Yes.
Footing is 300. So 1.5 minus 300. Only. Sorry? Until the slab, right? Until the ground level. It was the ground level, right? This is what we did here. Okay, so 1.5 is from the footing till the ground level. Then we added the blinding and we subtracted the topsoil. Yeah, so ground level, yes. Ground level. Because we will do the calculation for the slab. So this is up to the ground level. This 1.2 is up to the ground level. Okay, it's up to the ground level. So 1.5 from the footing till the ground level. Okay, from this we subtracted the footing, which is 0.3. So you get the column up to the ground level or whatever you have here. Okay, up to the slab level. Okay, because after that you will include the concrete of the slab. Okay, so this height is taken up to the bottom of the slab level. This is the bottom of the slab level. Okay, total was 150. Oh, sorry, 1,500 minus the footing only. Clear? Okay, so the column is from top of the footing till the bottom of the floor slab. Top of the footing till the bottom of the floor slab. Got it? Clear? Okay. And we have, again we have 8 columns, so multiply by 8. And the NRM sections which will go with these items are there. Okay, they are just snapshots from the NRM2 book. Okay, we are not doing the reinforcement because we don't have the sections right now. For the reinforcement you need the sections. It's given here, but I cannot explain obviously without the sections. Okay, then we have foundation backfilling. Okay, foundation backfilling. So we have 1 meter by 1 meter, which is the size of the foundation. 1 meter length, 1 meter breadth. Okay, and total was total was how much? It was how much did we estimate? 1.4, right? We estimated 1.4. Total height was 1 meter by 1 meter, 1.4 meter. Okay, so from this much we will subtract the thickness of the blinding and the footing. Okay, I excavated till the bottom of the blinding, right? I excavated till the bottom of the blinding. Okay, so from the total height, which was 1.4, you can see at the top 1.4. From this 1.54, I will subtract the blinding 50 millimeters and 300 millimeters of the footing. Okay, so 1.4 minus 50 minus 300. Okay, so you get 1.05. Okay, and the breadth was 1, the length was 1. Okay, clear? But in this one, we also filled concrete for what? We also filled concrete for the column, right? So this must also be subtracted from the backfilling because this is already concrete, right? I don't need to backfill it. Got my point? You did the excavation up to the blinding, then you filled the blinding, then you filled the footing, and then you filled the column. Okay, so we will subtract all of these and the remaining will be backfilling. Okay, so 1 meter by 1 meter straight, 8 footings, 1 meter by 1 meter, total excavation was 1.4. From there I subtracted the height of the blinding and the height of the footing. So remaining is 1.05. Got it? Okay. But this is not the total backfilling because I filled the columns as well. So 8 columns, 0.3 by 0.3 and same height obviously. Same height which I already, because I'm doing it from this. I will do the backfilling for the portion I did the excavation for, right? Okay. Am I clear or not? Huh? Your column is going up to 1.2 meters, right? Your column is going up to 1.2 meters. Okay, but that includes the hard core and everything. So in 1.2 meters, I will do filling of 150 millimeters of hard core. I will not do the backfilling. Okay, so this is why the column height was 1.2 there, and here it is 1.05 because this is for backfilling. Okay, so from 1.2 I subtracted the 150 millimeters of hard core, which I will fill with the hard core, the other material. This is backfilling of the same soil. Clear or not? Huh? Clear everybody? Ahmed? Clear? Okay. So whatever you will get, it will be your backfilling. Okay. Then the formwork to the column. Who will explain me this? 1.2. The height is 1.2. Okay. What else? And there is another 1.2. There are two, right? 1 point. It's a square, like square dimension, meter square, right? 1.2 into 1.2. Yes. 0.3 multiplied by 4. 4 sides, right? 4 sides of the column. Okay, this is height of the column. Okay, this is the height of the column. Height goes after, right? There is the height of the column and this is the girth of the column. 4 sides. Each side is 0.3, 0.3, 0.3, 0.3. Got it? Clear?
The area multiplied by height,
No. This is not the area. This is the perimeter of the column. We are doing it for formwork. Okay, so height is 1.2 and you don't take the area, you take the perimeter. Okay, and each is 0.3, each side is 0.3, 0.3, 0.3, 0.3. So total 1.2. Clear? Okay. Okay. We didn't do the formwork for footing and we didn't do the formwork for blinding as well. All of them are concrete. All of them are concrete. Okay, and all of them are filled in C2. There is no such thing as, up till now, maybe in future it will be, but there is no such thing as precast footing. Footing is never precast. So where is the formwork of the precast? Where is the formwork of the footing? Where is the formwork of the footing? Where inside? But we didn't calculate it. We will calculate it. She will do it, inshallah, for her project. Okay. We don't. What? We don't have the formwork for footing. And the reason is, why are you doing the formwork for concrete? Because why concrete needs formwork? To shape it, right? Okay, so we need the supports. And where is the footing? On the ground. Do we have the support?
Yes.
We have, right? Okay, that's why we do the blending as well. So the actual concrete is on a firm support, level support, not on the ground. And the sides, again, your excavation is the sides. The thing which you excavated is the same size as the footing, right? Same size of the footing. You need 1 meter by 1 meter footing. Your excavation is 1 meter by 1 meter. Okay, so you don't need to worry about the sides and you don't need to worry about the bottom. No formwork required. But the column over the footing, right? So we still need the sides to be supported. Okay, the excavation is 1 meter by 1 meter. Column is 300. So you need the support from the sides. Okay, what else are we doing? Okay, 9.3 and 6.3. 9.3 and 6.3. This was the external girth. This was the external girth. Okay, now I am going to fill hardcore inside the plot. I am going to fill hardcore inside the plot. So I need internal girths now. Okay, or the internal dimensions. I need the internal dimensions. Okay, so from each side they are subtracting 300, 300. Okay, 300 column here, 300 column here, right? Each side we have a column. Okay, and the column is 300 by 300. Okay, so 300 subtracted from here, 300 subtracted from here. Okay, you will get the internal dimension 8.7. And same thing for the other side. It was 9.3 external. You subtract one column from here, one column here, you get 8.7, yeah, and 6.3, one column from here, one column from here, you get 5.7. Got it? Okay, so this is the internal dimensions. These are the internal dimensions for the hard core, because hard core is inside, right? Inside the plot. We don't need hard core outside the slab. Okay, so the internal dimensions multiplied by the thickness of the hard core, which is 150 millimeters. Clear? Okay, and this is not part of backfilling, it's a special material. Then we have the concrete slab and the ground beams. Okay, we are still doing the substructure. So ground beams are in the substructure. Okay, ground beams are part of the substructure. Okay, under the walls or whatever you call it. Okay. So 9.3 and 6.3. What was it? Center, inside, outside, what? External, right? This is external. Okay. So we are taking it for the slab. This is the slab. Sorry? No. Because you are, who said that? No. You are taking column up to what? The bottom of the slab. You are taking column up to the bottom of the slab. I told you this is the rule, even for superstructure. Column height is taken up to the bottom of the slab. So slab concrete is part of the slab. Okay? Where is it? We took the column height up to the bottom of the slab, or up to the ground level, whatever you call it. Okay? So we did not include this part into the column. So I have to include this part in the slab now, right? Otherwise this will be left. Getting my point? Everybody? Sure. If you take column up to the slab, then the edges are covered. But you took the column up to the bottom. So the edge is, this part is not covered in the column. Now you have to cover it in the slab. Okay, we need the same quantity of concrete. Okay. So, what was I saying? Okay, concrete slab and the ground beams, they are calling it the ground beams. Okay, but you don't see any beams here, right? Okay, we took the column up to here. Okay, so could be, it's not written here obviously, but I'm just explaining. There are some beams which are called as I forgot the name, but they are like part of the slab. They are within the slab. Okay, so like you don't see any beams here, right? Okay, so sometimes there is a beam given but the beam thickness is same thickness as the slab. So there is, it's not like this. This is your slab. Okay, the normal beam is like this, right? You see it under the slab. But there are some beams which can be part of the slab. Their thickness is same as the slab. It can happen. Okay, so this is what it looks like because we took it within the slab. Obviously, we will cast it together, right? If the beam is like this, we will cast it together, right? Okay, so that's why. So external dimension, because the column is not part of the slab, and the thickness of the slab. Clear? We have only one slab in the whole area, one slab. Okay. Then we have what? This is for the walls, right? Is this for the walls? Which one is it?
This one is a
Walls, yeah, walls. 250? No. Concrete. This is which one now? Did we miss something? We did the hard core, we did the ground slab, okay, and this is what now? This is for the beam, okay. Okay, we have calculated the beams separately. These are the beams, these are ground beams. Okay, these are ground beams. Okay, so for the beams they are taking the center line, the same dimensions which are given. Okay, so for the beams, for the walls, you can take the center line dimension for the beams and for the walls. Okay, so we have one beam there. Okay, and we have, they are taking it now different, like this panel and this panel and this panel. They are taking it into 3 parts. Okay, so each part is, you can see on the top, 3 meters. Okay, so we have 3 beams here, okay, and 2 sides. So that's why 2 into 3. Okay, what is the length of the beam? Length of the beam is 3 meters. Each beam. Okay, and this is the thickness of the beam, and this is the height of the beam. Okay, it's not written anywhere. It should, anyways. And this is the other side, the vertical dimension. Okay, the length is 6. Okay, and the thickness and the height are same. Clear? So these are the ground beams which are under the wall. Anything which aligns with the wall is taken with center line dimension. Okay, so that's why. Then formwork for the beam, you have beam will be with the slab itself. We'll cast a beam with the slab. Okay, it's an attached beam. Okay, so you have to take the girth for the beams which are on the perimeters. Beams which are on the edges, you have to take the girth including the slab. Okay, so you can see 150 millimeter, the thickness of the slab, 300 millimeters, the width of the beam. Okay, the thickness of the beam, the width of the beam, and 350 means 150 of the beam plus 200 of the slab. Okay, the total girth for the formwork is 150 plus 300 plus 350. Okay, and this will be done for each beam on the perimeter. The same girth, because the beam size is same, right? The beam size is same. So each beam which is on the perimeter will have the same girth. All beams which are on the perimeter will have the same girth. Okay. Do we have any internal beams? We don't have, right? You go back here. 2 beams in this direction. Where are they? On the edges, right? Okay. And 3 beams each in each of these directions, right? Any internal beams? There are no internal beams. Okay. So that means what? You will use the same girth for all these beams. 2 in 6 meter direction and 3 meter, 3 meter, 3 meter. both sides. Okay, so they are 2 plus 6, total 8 beams. Okay. Guys, multiply by the length. Okay. They took the length to the external, so they are not doing in panels. Okay, formwork they are not doing in panels. Clear? Clear or not? One difference you will see from the concrete of the beam and the formwork of the beam is the dimension. For concrete, you are taking center line dimension, right? For concrete, you are taking center line dimension. Okay, but formwork is still the end, right? Formwork is still the end. So they are taking the external dimension, you can see. Okay, and they are doing it in one go. Okay, they are not doing it in panels. You see the 9 meter direction? What did we do with the concrete? 3 meter, 3 meter, 3 meter, right? Okay, formwork? No. From one end to the other end, same. Okay, 1 unit. 9.3. From one end of the slab to the other end of the slab. Got it? Clear? Clear? And the reason is, as I mentioned earlier, the same thing which I mentioned for the girth. When you are taking the height of the formwork from this side, from your left hand side, you are taking it with the slab, right? You are taking it with the slab. So obviously the beam is casted with the slab, right? So slab is still the external, right? Slab is not center line. Okay? So the beam is casted with the slab. So you have to take the length up to the slab. Okay? And for slab we took the external. Okay? So this 9.3 and 6.3 are the edges of the slab. Clear? Okay. For concrete you can do paneling and each beam separately, no problem. But formwork will be till the end of the slab because they are attached. Okay? Any questions? Okay. What is the next item? Okay. Now we are done up to the ground level, up to the floor level, sorry. We are done up to the floor level. Excavation, filling, column, beam, everything done. Okay. Now we are going to the top. And we are starting with the concrete of the columns. Okay. So columns are usually continued from the ground till the top. Columns usually do not change. Okay, because you will have other problems with the structure. Okay, I hope they will explain it to you in the structure courses. I'm not good at it. But if you are changing the size of the column from one floor to the other floor, it can cause some deflection and something. Okay, so 0.3 by 0.3 size of the column. 2.4 is the height of the column. Okay, and the height starts from the floor level, not the ground, the floor level, and goes up to what? Goes up to what? You are already at the ground level. Superstructure. You are going on top. Yes? The bottom of the beam. Okay? And the beam is, you can see here, it was from floor to ceiling, it was 2700. Okay? And they are taking here 2.4. So that means the beam is how much? 300. Okay? Same thing should be for the top as well. From floor to ceiling, 3250. You subtract the 300 of the beam, you get 2.95. Okay? We have the same 8 columns, we have the same the same dimension, the same square 8 columns. Okay, clear? Then you have the formwork to the columns. 1.2 we know that, right? The perimeter. Okay, and the height is up to the slab now, right? Okay, the height is up to the slab. Okay, so the beam is included in it. Okay, they did not subtract the beam for the formwork. They did it with the beam. Okay, so the formwork of the column is with the beam in this case. Okay, concrete for the floor slab. Okay, so you will take the external dimensions again and the floor slab thickness. Okay, and 2, because both floors have the same area, right? The area is not changing, it's the same area. Okay, so multiply by 2, you can do multiply by 2. Okay, if the area was changing, then I will not do this. Okay, then we have concrete for the beams. Okay, now here you can see some beams which are internal. Okay, are they internal beams? No, there are only 2 floors, no internal beams, but they are showing it, right? We have this one, okay. They are showing that. They should be how much? 2, no. 2 into should be 4. 2 into 2 should be 2 into 2. Okay, so the top 2 which you see is for the 2 floors, because the beams on both floors have the same size. Okay, and they are one after another. Okay, and yeah, okay, I will finish after this. So there is something missing here. There should be another 2 here. Okay, because if you see here, you can see these beams, right? Okay, so these internal beams are missing. Okay, so there should be something. It should be the 6 meters should be 2 into 2. Okay, so put the dash, but they forgot to put the 2 here. Okay, so there are 4 beams here. 4 beams, 2 on the sides, 2 in the 2 in the region. Okay, should be 2 into 2. But you get the point, right? Okay, we are taking center line. Okay, and for the top one and the bottom one, each one is 3 meters. 3 beams here, 3 beams here. So 2 into 3. Okay, and for this one, the vertical ones I told you should be 2 into 2. 2 for the sides, 2 in the region. Okay, and 2 on the top because of the floor, because we have 2 floors. So this whole thing will give you for one floor, then you multiply with the 2, so it will become for both floors. Okay, then you have the formwork for the soffit of the slab. Soffit means the bottom of the slab. Okay, so for bottom, now we are taking the internal dimensions. Okay, we are taking the internal dimensions. So it was 6 meters. Each panel is 6 meter by 3 meter. Now remember, you did the beam. You already did the beam, right? Okay, so I can take each panel now. Okay, so this panel was 3 from here to here. Okay, I'll subtract half of the beam from here, half of the beam from here. Beam is 300 millimeters. Okay, so 150 from here, 150 from here. So 3 meters minus 150 from here, 150 from here, you will get 2.7. And this one is 6 meters. Again, half beam from there, half beam from the bottom, you will get 5.7. Okay, and then you have 3 panels. Okay, so 3 on one side, 3 on the other side, and for the ground floor and for the first floor. Okay, I think the numbers should be correct. The numbers should be correct. This is 3 only on one side. There should be 3 into 2. for the other side. No, this is the slab. Sorry, the numbers are correct. Okay, sorry. This is for the slab. Yes. Okay, any question up till here? All clear? Okay. So don't forget the presentations. We will start with the presentations. So come early. And who didn't do the attendance? Who didn't do the attendance? Mariam Sara. Okay. All of you are done with the attendance? You didn't do as well. So you do this. Okay. Thank you.